I wanted to show you guys one last thing though. This is sort of the crux of what this lesson is all about. We're going to start talking about, we're going to learn one new simplifying step. So we know about combining like terms. I know that I can take all of these ones and put them together, and instead of saying 1 plus 1 plus 1, I get 3. I know that. You guys should know that too. I know that I can remove 0 pairs from I know that I can remove 0 pairs from the top and the bottom if they're the same value like this. I know I can remove opposite amounts from the same side like this. But today what we're going to talk about is the one last thing, and that is, like, some students might still be confused about what is bigger, x plus 1 or x minus 3. I don't know what x is, so how do I know which one of these is bigger? And what we're going to learn today is one last thing that is called, let's see, text. It's called removing balanced sets. And what that means is removing the same thing, the same value from both sides to stay, to preserve the balance in an equation. Okay, so that's a lot of words. What does that really mean? Well, it's like, it sort of works the same way as a teeter-totter. Let's pretend that this is a, where's my marker? Okay, let's pretend that this is like a teeter-totter, okay? So there's a teeter-totter. You guys ever go to the park and see one of these things where you got like 2 kids and they're like, well, you got a kid sitting over on this side, here he is sitting here, and you got another kid sitting over on this side, and like they go up or they go down, and like, how many people have seen this in the park before? I'm gonna lower all hands and then raise your hand. Show me your blue hand if you know what I'm talking about. Some people call it a seesaw. Some people call it a teeter-totter. I don't know what other people call it. But it works sort of the same way as like a balance scale. So if one kid is really big, right? If you got one kid, like if my 2 girls get on it, my daughter is 7 and she gets on it with her 4-year-old sister. 4-year-old sister is going up because she's smaller, and 7-year-old sister is going down because she's bigger, right? Y'all follow that? So, so in order to like whether they're the same or whether they're not, let's say they're the same. Let's say that my daughter, my 3-year-old gets on, or my 4-year-old gets on with another 4-year-old. What if we add weight to one side? Let's say that we give, I give Orla her backpack. So now she's got her backpack on. What's gonna happen now that I put her backpack on? What's gonna happen to her? Somebody unmute and let me know.
So he will go down?
She's gonna go down, right? It's gonna change the balance of things, right? How can I prevent her from going down? What could I do to prevent that from happening?
We could add weight to the other side.
If you add weight to this side, if we add a backpack of the same weight to the kid over here, then they're gonna stay balanced, right? The weight of this one is gonna pull down the same amount and they should stay balanced. Or I could take away the backpack. You know, if I take the backpack off, what happens if Orla takes her backpack off? Bye-bye backpack, right? Here it is out here. Then this extra weight goes away and this side the left side is gonna pull down. What could I do to cancel that out?
Remove her backpack.
I can remove her backpack from this side. So like that would be the same thing, right? That would remove this weight being pulled down too, and they would stay balanced. And the same thing would happen if they were unbalanced, right? If I gave weight to Orla, she's gonna pull down again, unless I put the weight back on Winnie, and then Winnie's gonna pull down again. And then if I took weight off of Winnie, right? If that weight goes away, then Orla will go back down. But if Orla's weight goes away, then she'll go back up. It doesn't matter whether it's a balanced equation or an imbalanced inequality. It doesn't matter. the point is that either way, you will make the, either way, you change the balance, or you keep the balance the same if you add the same amount to both sides, or the imbalance will be the same if you add the same amount to both sides. So in this case, when I'm looking at these expressions here, do we see anything that is the same size on both sides?
X.
X. So I can actually take this X and I can remove it from this side, and normally that would be not cool. That'd be like, look, you took off Orla's backpack, but you didn't take off the other kid's backpack. But if I also take the backpack off the other side, if those are both gone, the balance between these two things is preserved. And so they're still not equal, but it makes it, if people are like, I don't know what X means, that's confusing. One thing we can do is, if you take an X away from both sides, and you have to take it away from the top of both sides, but if you take it away from both sides, then it becomes even easier to see this is just -3 and this is 1. Which one of those is bigger? -3 or 1? Go ahead and write that in the chat for me. We got like 10 minutes left. 1 is bigger. Everybody's writing 1 in the chat. Good, 1 is bigger. So when I go here, right, I can say, oops, now I have to erase all of the annotation. I'm gonna erase all that now. Clear the annotation, clear all drawings. When I go here, I can look at all of these answers and go, okay, all of these are bigger. But if I kept simplifying, I would just have -3 and 1, and I know which one's bigger. So the next question says, which map from number 1 is greater? And we've sort of already talked about that. You guys have already written in the chat 1. Somebody wrote in -1, but -1 wasn't a choice. Our options were 1 and 3. So, or 1 and -3. Those were our two choices. So 1 is bigger. -1 is also still bigger than -3. But the mat is greater because no matter what X is, subtracting 1 is always going to be bigger than subtracting 3. Or if I remove the X from both sides, the difference is -3 or and +1. +1 is larger. I mean, those are possible answers here. So you can write in whatever you want. Your words aren't going to match mine here, and so it's going to mark it red. But as long as you understand that this is this is bigger because the leftover tiles represent a higher number on the right than they do on the left, then you understand what I want you to understand. So we only have like 8 minutes left of class. I'm going to give you this 8 minutes, and we will be working on this tomorrow too. I'm going to give you the 8 minutes to go through and explain, right? What did you do on the, so you guys are going to look at this one.